Welcome to BKSS Academy. Now we are discussing about hill climbing algorithm with a question. Suppose this is the initial state B, C, D, A and final state is A, B, C, D. For solving a hill climbing problem, we have to use two approaches, that is local heuristic and global heuristic. In local heuristic, formula is for every right resting bonus will be +1 and for every wrong resting bonus will be -1. So when initial state is this and goal state is this, we have to convert initial state to goal state. So initial state's calculation will be like this: B, C, D, A. B is at the wrong position, so it will be awarded with -1. C is at the right position because of above B, so it is +1. D is at the right position above C, it is +1. A is at the wrong position, it is -1. So always local heuristic is calculating the resting position on which variable, above which variable the variable is the next variable is there. Suppose C is at here, that means C is over B, it is correct, but the nearest variable it is calculating. D is over C, it is correct, but A is not over D. A is to be stayed at here at the base. So we will calculate on the next step. It is 0. Total value is, goal state value is 4 and this value is 0. So distance is 4. This is 1, this is 1, this is 1, this is 1. It is 4. This is -1, this is 1, this is 1, this is -1. It becomes 0. So if we will convert this 0 to 4, then we will reach at the goal state. So coming to the next step. Suppose we are at this position, then we will go for the next step. We can move A to this side. So what it will be? B, C, D and A. This will be another positioning after this. So this will be -1, this will be 1, this will be 1, this will be 1. So my result will be 3 minus 1 is equal to 2. That means from 0 to 4, suppose we are moving 0 to 4. 1, 2, 3. 1, 2, 3. On first step, I was at 0 in the initial state and goal was 4. On the next iteration, we are at the 2. So we are moving at the right direction. Distance is becoming less. Then there is another probability on the next step. This D has the position of resting over A and D has the position resting after A on the base. So what it will be like? BC AD or BC AD. BC AD, BC AD. As per this formula, D can be resting over A or D can be resting at the base. So we will calculate this one. If B is equal to B at the wrong position -1, C is at the right position, it is +1, A is at the right position +1, D is at the wrong position -1. So that becomes 0. -1, 1, -1, -1, 1. That becomes 0. Similarly here, B is at the wrong position -1, C is at the right position 1, A is at the right position 1, D is at the wrong position -1. So this also becomes 0 because 1 minus 1 1 minus 1 becomes 0. So again we are on this map, again we are moving to this location. We are on the next iteration, we are at the closest position of 4, that is 2. 4 is the goal state value. But at the next iteration we are again backing to the 0. So here local heuristic becomes failed. Local heuristic becomes failed. Local heuristic becomes failed. Then we are going for global heuristic. As we know, there is 2 ways of solving the problem. Local heuristic, that I had done, what the things I had done, in this way I am doing it. On the first iteration it was 2, on the second iteration it becomes 0. So same 0 is repeated, because of that local heuristic becomes cancelled. So we cannot proceed with local heuristic. That is over. Then I am going for global heuristic. Global heuristic formula is base position will be given 0, correct support structure will be +1 for each variable. For each variable. Wrong support structure will be -1 for each variable. And its formula is to total structural position. Total structural position. It will always consider structural position, whereas in local heuristic only local positioning or resting position we are used to consider there. So it is the goal state, it is the final initial state, and this is the goal state. As per this principle, BCDA is the initial state, base position will be avoided with 0, C is not at the right positioning because of C is above B, B is above A. Because of A is not here, so under C how much variable is there? That is only 1, so it will be -1. Similarly, D is not at the right structural position because of B is over C, C is over D, it is correct, but B is not over A. So D is considering how much variables are there under him. So 2 variables, it will be -2. Similarly, A will be -3. So total will be -6. In case of goal state, it is 0, 1, 2. Everything structural position is 3. A structural position is correct. So 0, 1, 2, 3 is there. So it becomes 6. So if we will reduce -6 to 6, my result will be, we will be able to reach at the final state. On the first step, I will down this A. On the initial state it was -6, I will down this A to base. So it becomes BCDA. Base value will be 0 as per the formula. C is at the wrong structural positioning because of A is not here. Under C, 1 variable is there, that is -1. Under D, 2 variables are there, -2. So -2, -1, -3. So value is -3. From distance from -6 to 6 was there. This is the distance. It is the initial state. It is the goal state. This value. Initial state and goal state. So this is the initial state. This is the goal state. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. So this is the total distance is 12. If we will reduce this 12 distance to 0, so we will reach at the goal state. So here on the first calculation, my value is -3. So it is reducing the distance, -3. Then D has the, if distance is reducing, that means we are at the right track. Similarly, B and C, this D will be at the base. So 0, 0, 0, and this was -1, -1 we are getting, because of -1 is nearer to 6 as compared to -3, so we are at the right track of reaching at the goal state. Similarly, we are going for this C will be converted to transport to base. So BADC. So all values are 0. Calculation is 0. 0 is nearer to 6 as compared to -1. That means we are at the right track. Similarly, we will calculate A and B. B will be over A on the next step. So ABDC, as my value is total value is 1, which is nearer to 6 as compared to 0. So we are at the right track on this location. On this way we have to calculate. Any other combination will be giving you the wrong result. Similarly, A, B, C, D, this C will be over this one. Then my result is coming 3, which is close to 6. So this is we are at the right direction of reaching at the goal state. Similarly, D will be over the C. So total structural position is okay. So 0, 1, 2, 3, that will be 6. 6 is equal to 6, which is the value of goal state. So we are at the goal state after this location. You may ask me, sir, why this way we are arranging? We may keep A over B, C over D. On this way, machine will think, artificial intelligent machine will think, what will be my calculation so that I will be close to the goal state. If I will keep A over C, my value will be again to the minus negative. That will be again going for becoming distant from the goal state. So this is why we are the machine is arranging in such a way. Thank you.